Hello class, this is Mrs. Gregory. This is again for Algebra 1B. This is your practice lesson 55. It's on page 357 and I'm going to review problems A through F. So you'll need to go ahead and open your book, hopefully have your solutions in front of you. Please do not watch this video until you've attempted every one of these problems because I'm about to give you the solutions. All right? Before I actually do that, I left off with your last video, and what I found my error to example number 5. Okay, so if you want to look at and I'm going to do this very quickly, the one thing I didn't do is when I graphed one graph, I did not count correctly. So the final answer was 2.5 and 25, which meant, so we were renting a bike, so at 2.5 hours, both of them, if I were renting the bike for 2.5 hours, it would cost me $25. That's what that means. And I had just not graphed these correctly. All right, so I'm very sorry about that. But let me put that away and move on. All right. A and B are not difficult. I do have the answers here, so I'm going to go ahead and open those up. I don't want to give you the answers to the practice sets. But I want us to go ahead and look at this. We're going to start with A and B. All right, and so we'll start with those. And all we're doing here is determining if the solution given is a real solution, yes or no. Okay, and I'll work those out. Then I'm going to solve. I'm going to graph these two, C and D. By the way, you could have done E. I'm going to give you a rundown on that. I did not graph it because it is not very good for graphing on regular graph paper. Because when you finally did do it, your answer would be 8.4, negative 3.6. So those of you who were able to do it on your calculator and you found this to be your solution, that's wonderful. And if anyone did, please let me know. All right, please let me know because I'd be very interested in you and knowing if you got a graphing calculator that you know how to use. All right, and then I went straight to F and I graphed this also. It was not an easy graph because of these numbers being real big, but I'm going to show you my solution. Okay, so let me go ahead and get started. All right, with A, here's the original problem. Always write your original problem. I got 1, 3 is the solution. We're to determine, is this a solution to this linear equations, to the system of linear equations, because a system means there's more than one equation, okay, and they're related to each other. In this case, we're just going to substitute 1, 3 into 2x plus 5, 2x plus y equals 5, loading in the data. It turns out that 1, 3 is a solution. All right, hopefully yours looks like mine. And do again the same thing to the second equation, and it turns out again they are. So yes, 1, 3 is a solution. Remember, you can say yes or no. All right, the answer yes is correct, but you got to show me why. All right, I know that was quick. If you need to go through this again, pause the video, back it up a little bit, and go again. Same thing with 3, 4. All right, with B, 3, 4 going into 2x plus y equals 5, 2x plus 2y equals 8. This is our system of linear equations. I substitute those values. I end up with 2 times 3 plus 4 equals 5. And it turns out, no, 10 is nowhere equal to 5. So no, it's not a solution here. Immediately, it is not a solution to, I could stop here. I don't have to go any farther. But I know that 3, 4 is not a solution to the first equation, which means it's not a solution to this system. But I went ahead and did 3, 4 for the next one. 2x plus 2y equals 8. And I threw those values in, which gave me 6 plus 8 equals 8. 14 is not equal to 8. So again, so my final answer is no. 3, 4 is not a solution for either equation. All right. In fact, that it's not either one, then it is not for this linear system. All right. Let's go on to C. C gave us 2 equations, and so nice of them to give them to us already in y equals mx plus b form. This one was not too difficult because all I had to do was graph them. All right, so of course I went ahead and maintained my green and red. So my first equation, 2x minus 5, I start it in minus 5. go up 2 over 1, up 2 over 1. And I do it several times so that I can get several points. And it was straight line here. Then the next equation, y equals x minus 3. All right, go ahead and graph that. Start at -3, go up 1 over 1, up 1 over 1, because our slope is 1 over 1. And we end up with our solution at 2, -1. All right, now I can prove it, okay, by doing the same thing, by loading these values into my original problems. And it turned out, yes, both of them worked. So this one, C, was relatively easy if you understood how to graph and how to determine that the solution was right. All right, going on to D. D was not hard, except for D was a difficult one to graph. Let me go ahead and show you the graph. Here's the original problems. Y equals 2x minus 5. And then the second equation is 3x plus y equals 15. By the way, this is not in y equals mx plus b format, so I changed it. I did that here. I moved the 3x to the other side. I end up with y equals -3x plus 15. I moved that here. So now I'm graphing this equation and this equation. All right. So my graph ended up being pretty big because of this being a big number at 15 and -5. This here is what really is my biggest issue because these are so far apart. So I went ahead and used a whole sheet of graph paper and graphing 2x. Let me go ahead and write that down. 2x minus 5. This is y equals 2x minus 5. Let me get a red pen and I'll write it on the other one. And this one is y is equal to, actually, let me put 3x. Let me change that to 3x plus y is equal to 15. That's this equation, all right? So when I graph them, all right, this one I start at -5. I go up by 2, 1, 2 over 1, 1, 2 over 1. Guess what? There's my green line. Then I did it again. This one I started with 15, and I come down 3, 1, 2, 3 over 1, down 3 over 1, and I just kept going, and all of a sudden I found that it landed right on that spot right there. And so I ended up with my solution being 4, 3, and then, since that was my solution, I did just do a quick check, and it is true for both. This is the solution for both those equations, and so the final solution, 4, 3, is good. All right, I'm not going to go over E because E would not have been a good one to graph for many reasons. And so I decided to go straight to F. So if you didn't do E or you did it on your own calculator, that would have been good. But that was not a really good problem. E is not a good problem for graphing. All right, it's not a good problem for graphing on just paper, you and me paper, because we don't have that precise of a graph. There's no way we're going to get to 8.4 and -3.6. All right, that's just not going to happen with paper and pencil. So I'm giving you the option to move out of that one. Now let's go on straight to F, and F is a word problem. Okay, these kind of word problems do seem to come up quite a bit, so I want you to be aware of them. All right. This one says Jill has $20 in her savings account and plans to deposit $5 each week. Jose has $5 in his account and plans to deposit $10 each week. After how many weeks will they have the same amount of money in their accounts? And what is that amount? Okay, now this is a lot to think about, but we're going to sit here and realize that this is an account. She starts with $20, Jill starts with $20, and she's going to increment her the money into the account by $5 per week. Jose has a similar situation, but he starts with $5, but he's going to start saving at $10 each week. Okay, so let's go ahead and show how we can show that algebraically. All right, let me go ahead and cover that real quick because this kind of gives us our overall what we want. First, Jill, I set Y is equal to the amount of money in the savings account, and I set X as the number of weeks. Okay, they're saving the number of weeks they've been saving. So here's the question. After how many weeks will they have the same amount of money? And what is that amount of money? Now, I'm going to say this graph is not terrible, but I couldn't do it by ones. I went ahead and did this by 5s along my Y. All right, I graphed it. And when I graphed it, Jill starts at $20 and she goes up by 5 because I did this by 5s, 5, 10, 15, 20, 25, 30. So she goes up by 5, and in week number 1, she has $25. And she goes next week, all right, she goes up by another 5, and it ends up in week number 2, she ends up with $30. And then after 3 weeks, all right, so you see what that means. And I went ahead and graphed Jill. Well, Jose started a little lower. He started at $5, okay? That's his initial value, all right? Then he adds $10 in the first week, and it puts him in the first week. He's now got $15, and another week he adds $10, so he ends up with $25 in week 2. And then in week 3, we go up. He ends up in week 3 at $35. Now, when I go ahead and graph this, we easily see that these two intersect at 3 weeks, and at 3 weeks both of them have $35. So here's our final solution. Our solution is $335, and after 3 weeks both Jill and Jose will have saved $35 in their savings account. Okay, so that pretty much encompasses both those questions with that sentence. All right, so long as you understand what these two numbers mean, what they represent, that's very helpful. All right, I hope this was a help. Have a good day.